somebody really finds a good way to cheaply capture that CO2.
But while seaweed is growing, it releases a lot of carbon into the ocean, doing carbon capture at the same time that it's
a whole new technology that gets rid of all the problems and turns them into solutions.
You have to generate technology that have to be affordable.
Yes. With the growing population, there is a growing demand for food, for proteins, and industry is thinking of better ways to making more sustainable.
I'm optimistic, but no, the time to take action was like 10 years ago.
Ladies and gentlemen.
Bite-sized climate tech. Hello Tomorrow Summit Special. Let's make climate cool again.
This is the chairman of QPT.
Hello, lovely to meet you. Yes, I'm James, chairman of QPT.
His company is really, really interesting just by hearing what he said about this.
So this is a model of the world's first gallium nitride high-frequency motor drive, which is a big scientific mouthful, but really it's quite simple. 45% of the world's energy is used by electric motors. So that's industrial, electric vehicles. Big one is heat pumps and air conditioning systems. They're just electric motors. To control the speed of an electric motor, you need a thing called a variable frequency drive or a motor drive. It just allows you to control the speed, right? Otherwise, it's a bit useless. Your car is just on or off, your heat pump. So we all need these. And inside these are lots of switches called transistors. And the faster you can switch the transistor, the less energy is wasted. Every time it switches, it loses a little bit of power. So the cool thing is the faster you can switch, the more power you save. Now, traditionally, these transistors have been made of silicon. Everybody's heard of Silicon Valley, silicon transistors. And recently there have been a thing called a silicon carbide transistor, which is a bit quicker. About 10 years ago, a wonderful transistor came out called a GaN transistor, gallium nitride transistor. It is crazy fast. But when you try and switch really, really, really fast at high power to drive an electric motor, you get these insane thermal and electromagnetic issues. So today, GaN has been used for low power applications, mobile phone chargers, laptops, power supplies, but never, despite many years of trying, has anyone ever been able to solve those thermal and electromagnetic issues. So this is super exciting. It's a 10 horsepower drive. It's about 100 times smaller than the one you could buy today. It's about 10% more efficient. 45% of the world's energy used by electric motors. If we can save 10%, the environmental prize is, that is the equivalent of taking all of the planes out of the sky.
So this is the industrial use that has not existed yet. Now it's just using the low power density thing.
Gallium nitride today, everybody's really excited about GaN today. It's a big market. But yes, it's low power, next generation mobile phone chargers, power supplies.
This is the equivalent for the mobile phone, but for industrial practice.
Yes, it's the first time GaN has been used, not just for industrial. I mean, this is for would be probably for an industrial motor. But again, it could be a drive in an electric vehicle or, as I say, heat pumps and air conditioning systems.
How would you explain this to an 8-year-old?
Right, so electric motors are really cool, right? 8-year-olds love electric cars, right? They've probably heard of electric car Teslas and things like that. And they're super cool and they're really good for the environment. We love electric motors. They're so important. But we need to be able to control the speed of the car. We need to make the car go slow and we need to make the car go fast. And that's what this little box does. It helps the car to move slowly or quickly. And the problem is that these little boxes waste energy. They get hot, and when things get hot, they're losing energy, and that's sad because we're producing energy and electricity to make the car, and we don't want to waste it. It's all the carbon emissions that are hurting the planet. It's a special magic box that helps the electric car just move around without wasting as much energy, and that's really good for the environment.
That's great. The question from a previous guest.
We know that things are getting worse with our climate. When are we going to know it can't get any more worse? What does that limit look like?
Oh, wow. I mean, I hope I mean, naively, I hope we're past that. You know, I mean, last year was officially the first year where we had, you know, we're above the 1.5.
Yeah.
You know, I think we're past that point.
I think that's it.
What's wonderful around here is like, look, I mean, I'm talking about 10% of 45%. So this little magic box can maybe save 3 or 4% of global emissions. We only need a few companies to move the needle 1 or 2%, and we can solve the net zero problem. So I'm optimistic, but no, the time to take action was like 10 years ago. So let's make climate cool again.
So we have the CTO of Bezos. Hello, good morning. I'm Adriana. I'm CTO of Bezos. I'm also co-founder of the company, and we develop seaweed-based packaging to replace single-use plastic. So if you can tell me a little bit behind the technology of your packaging. Easier to showcase while looking at the products we have here. Basically, conventional plastic is made from granulates. These are normally fossil-based, so they come from petroleum sources, and they are converted into final types of packaging items, be that bottles, lids, for example, which is more semi-rigid, also types of films that can be used for transparent windows or to package food items. Yeah. So these are all your products? These are all our products, and our expertise lies in making different types of pellets of these granulates that can be converted to different types of final packaging items. Oh, so these are all from seaweed? These are all from seaweed. These are 80% seaweed polysaccharide in here. So this is the original? Exactly. This is the seaweed, so the raw material. Technology, how do you convert them? That's a very good question. So basically, we have a partner that extracts the polysaccharide from the seaweed, from the raw material, and then we use these polysaccharides combined with different types of bio-based plasticizers and functional fillers and extrude them. We use an industrial machine to make a filament, and then we cut the filament into these type of granulates. Oh, wow. And then there's another partner that converts these into a bottle, into a lid, into a film. So the technology, would you say, is extracted, or is it the whole process? It's mixing and coming into pellets that are being able to be transformed into final products. So this is our main expertise. I see.
How would you explain this to an 8-year-old?
That's a difficult question. I will try. So if I were to explain this to an 8-year-old, I would start by explaining that plastic packaging is made from small balls of materials that are put into machines and that are converted into a bottle or a film. And we make these balls from seaweed instead of relying on gasoline or petroleum, which is normally used for plastics that we have nowadays available mainly. So it's like super organic. Something that we can eat, but you can also use it for the packaging would no longer be like wasted. Home compostable and biodegradable material. Oh. So you answered a question from a previous guest.
I would love them to talk a little bit about the environmental impact of their technology, even if it's not directly related, maybe the way they're developing the product, because I would hope that anyone today, even if they're not doing something directly related to climate tech, is thinking about the impact on the environment of manufacturing their product or things like that.
That's a very good question, since by using seaweed, we can reduce carbon footprint quite high. Is that seaweed grows up to 3 times faster than land-based plants. It doesn't rely on fresh water to grow. It doesn't use pesticides or fertilizers to grow. And there's also research that shows that while seaweed is growing, it releases a lot of carbon into the ocean. Oh. So it's a way that doing carbon capture at the same time that it's growing. Yeah, that's brilliant. Let's make climate cool together. Thank you. Here I have the CEO of Futio. They have developed this nanotechnology, and I would like him to explain this to me first.
It's a Chilean startup that developed an additive. It's composed by a mix of nanoparticles, really small particles that you incorporate on different materials, for example, paint, asphalt, concrete, even in plastics or synthetic leather. And we promote a photosynthesis-like process on the surface. We can purify the air just painting, applying our nanotechnology there. We use photochemical reactions fractions, nanoparticles that we incorporate on different construction materials in order to promote this purification process. We transform buildings, facades, murals, or roads into huge air purifiers into the city. The technology behind is nanotechnology. We have an IP patent that is based on these nanoparticles that we developed. Because the nanoparticles that we use generate a synergical reaction that allow us to use all the solar spectrum of the light. I know it's really technical, but
no. That's the part you should explain.
Perfect. Yeah.
Okay, so your technology utilize all the spectrum of the light.
All the spectrum. Yeah. That's why we can use our nanoparticles in interiors, in exteriors, and we promote this photochemical reaction in order to capture greenhouse gases and local emissions. We can treat, for example, methane and also NOx, SOx, volatile organic compounds.
So when you're also doing the production, you can also remove...
We are going to treat gases during the lifetime of the final material. When you apply the paint, you're going to generate this process. Not during the manufacturing process, but during the use of the final product.
Yeah, so your product is the paint, right? Is it?
No, our final product is this. It's the additive. It's the slurry that is a mix of nanoparticles. You can apply directly into a gallon of paint. Indeed, this one is for a gallon of paint. You can apply this slurry directly into the paint, the gallon. It doesn't change the color, the gloss of the texture of the paint. But you obtain these decontaminating properties. And you are going to obtain this decontaminating process during the lifetime of the paint. You are going to promote this capture process for at least 5 years.
So the main goal is
to transform construction materials into something else that generate a positive impact in the environment.
How would you explain this to an 8-year-old?
This is a forest on your hand. It's like a tree, but using really small particles that generate something similar to the tree. We don't generate oxygen, but we generate the capture of the greenhouse gases pretty similar to the tree. So you're going to have a tree in your home just painting with photo.
Oh, that's so cool. So it's based on greenhouse gas removal technology.
That's why.
You also need to mention that because you can capture the whole spectrum. It's like the rainbow. If you explain to
a rainbow,
forest in your hand, then creates a rainbow.
Between that rainbow.
Yeah, to an 8-year-old. So the previous guest asked this question. How do they plan to scale up and what's the price they want to target? And how do they see the price influencing their impact and their readiness to have a marketable product?
We are really cost effective. For us, the cost and the price is really important in terms of this kind of technology.
How much cheaper is that?
$8 per gallon.
Oh.
Yeah, you have to generate technology that have to be affordable for the most of the people, because you are going to generate a solution for a really important problem that is air pollution. We have to have that in mind in order to generate this kind of technologies at the first moment, and we have that. Let's make climate
cool again.
Yes,
thank you so much. Thank you. So now I have a great female scientist with me.
Monica Tomesca.
Nice to meet you. Monica is
I'm a founding director of Fractionate.
You're going to explain the technology behind this.
So the technology is microfluidics-based filtration systems, which enable continuous manufacturing in bio-based production.
Yes, and your technology is also, compared to the existing technology, I understand, is much gentler.
That's correct. So bioproducers are normally using filters, membranes, and centrifuges to take their product out of the liquid. Our technology does this, but in much more gentle way, which means that we preserve more of their product.
That's a secret sauce behind the company.
How would you explain this to an 8-year-old?
If you think about it, people are already making food with microbes, and this production is already happening. By attaching our machines into their facilities, we actually make like a superhero of the production. They can actually make 10 times more product or 10 times more food in their existing infrastructure by just adding our system into the production line.
So they all of a sudden transform to a superhero. Thank you so much. So the question that left from the previous guest.
Why do you think that the problem that you are solving is important important?
Oh, it's extremely important. So this industry is actually struggling to grow to serve the population. At the moment, right, with the growing population, there is a growing demand for food, for proteins, and we are thinking, or industry is thinking of better ways to making more sustainable food for our populations. Our machine enables to make much more in already existing infrastructure, so that we basically boost the productivity. It's extremely important to do that.
So you also help, like, let's say if I want to eat a burger down the line, they can use your technology to, is it lab-grown meat, that kind of thing?
Absolutely. So lab-grown meat is actually using animal cells to make meat without actually killing the animal. So those guys are already doing those ideas, doing those productions, but at the moment it's very small scale. They need to be able to scale up their production to feed the population, and then that's exactly where we come in and make their production a superhero.
That's great. Let's make climate cool again.
No.
I'm so happy to be in the Hello Tomorrow event because I found so many people in climate tech. This is
Eric Matzner of Metal Plant.
He's going to tell me today is about this. This is an olivine rock.
So this kind of rock, when it breaks down, has the ability to remove carbon through the release of magnesium cations.
Yeah.
So we need to increase the surface area, so we grind it down and put it into fields.
Yes.
But there's trace levels of metals like nickel in this. So traditionally you can't use this rock, even though it's one of the most effective, fastest at breaking down, weathering. And so to overcome that, we use plants called hyperaccumulators that suck up nickel out of the soil as it's released from the mineral into their tissue. And then we harvest those plants and pull the nickel out of there.
Okay. Nickel would be your co-products. It's an amazing business model.
How would you explain this to an 8-year-old?
Well, for an 8-year-old, I like to think of this experiment when I was in elementary school where we had carnations, little flowers, and you would put food coloring in the water, and then the plant would draw it up through its stem and roots, and it would turn that color. So you can't really see the metal in the plants, but you can imagine the plant using its root to break down the minerals further and pull the metal out. And when it has the metal in its shell, it's like armor. And if a bug tries to eat it, it will be poisoned by the nickel. We harvest the carnation, and instead of taking the color out, we take the nickel out that's in there.
A question from a previous guest is,
what is their immediate impact of their first sale or first implementation of their technology?
The impact of the first deployment is conceptually, it's to help people understand that there's ways to overcome these kind of problems and turn what was a problem into a solution. And that's kind of what I hope to inspire others, is to like look at where technologies have stopped, or look at other technologies that have stopped and combine them together to get a whole new technology that gets rid of all the problems and turns them into solutions.
Oh, this is
Let's make climate cool again. Let's make the climate cool again.
Yeah, thank you, Eric.
You're welcome.
So I have Andre here with me. He has a hydrogen startup. I would ask him today about this specific topic. How is his technology better than anyone else to purify the hydrogen? You can do something that other people couldn't to the water or something?
To the hydrogen.
To the hydrogen.
To the hydrogen. But so it's a filter, right? So you push gases through, one gas goes through, the other gases don't go through. Right? For us, we just have a filter that's like better than what they use today. So filters today, they get clogged a lot.
Yes.
They don't filter well, or they age very quickly. They break down. And basically, we go to these startups and we tell them like, oh, you know how your filters clog, your filters break down. Ours will last much, much longer, and it'll do the filtration much, much better.
Why is yours better?
It's kind of like, I have another analogy there. So you know how old TVs were giant, big machines, and today TVs are little thin thing?
Yeah.
It's kind of the same thing. So old TVs, bear with me for a second, were photon cannons that shoot photons on a bioluminescent screen.
Okay.
Crazy complicated.
Yeah.
But that's the old technology. Today, for filters like this, is kind of what we do. We do this crazy complicated chemical thing, but in reality, the new TVs are way simpler. It's a little blinky light goes just red, right? Here's the same thing where you basically have, that's only possible because we can do miniaturization. Because we have the tools to make things way, way smaller, we can do a simpler thing. So our filters are way simpler just because they're way smaller, but that wasn't possible. Like they're actually like sub-nano molecular, like smaller than nano, polymer structures, plastic structures to actually do the filtration. I mean, that wasn't possible before.
Okay, what do you call your technology, the miniature thing?
The sub-nano molecular sieve, actually. That's the technical term.
Okay, so that's the technology.
A membrane filter.
A membrane filter.
Yeah, it's just a membrane filter.
Thank
Yeah.
you so
How
much.
would you explain this to an 8-year-old?
So we make hydrogen separation filters, which is a very fancy term for basically what you have in your chest. It's a lung. So when you breathe in, you actually breathe in 80% nitrogen, which is useless to you. You don't do anything. It's not harmful, but it doesn't do anything. And 20% of what you breathe is the oxygen, which you need in your blood and etc. And your lungs just separate it. The oxygen goes in your blood, the nitrogen you just breathe out. Similar thing here. We go to clients, we go to other startups or big refineries and companies that use hydrogen, and the hydrogen's mixed with other gases, and then they need a lung to essentially separate the hydrogen to be able to use it in big refineries and plants and stuff.
You answered a question from a previous guest.
Which technology do you think will have the greatest impact on the climate in the shortest time period?
Can I have two short answers? Okay, so one of them is methane leak detection and reduction. That's specifically because it's the shortest time period, because methane has a very large impact in the short term. Yeah. And so I don't have a specific startup for this, but any startup that's good at helping detect and fix methane will have a big impact in the short term. Other than that, anything that does actual helps doing carbon capture and sequestration or use. We talk a lot about carbon capture and sequestration. There's not actually a lot of people that actually, but there's not that much that actually does. I mean, people make like a bar of soap with it or something like that, right? Which is fine, but it's not good enough to be really large amounts. Yeah. And so I think if somebody really finds a good way to cheaply capture that CO2, that'll make a huge difference. So let's make the climate cool again.
Thank you.
Express podcasts are their own and do not necessarily reflect the official position of Bite-Size Climate Tech. We thank our guests for sharing their insights and experiences, and we thank you, our listeners, for joining us on this journey. Until next time.
What non-traditional startup have you recently heard about that you're very excited about?
Oh, that's a good question. Thank you very much.